This is the second video in our SQL tutorial series. In the previous video, we covered the essentials of SQL or SQL, giving you the skills to start selecting and filtering data. Today, we're going to dive a bit deeper into data types and how it all organized with tables. Over the next 20 minutes or so, we'll expand your SQL journey with tables, what they are, how to create tables, and how to manipulate data in them. This is really a crucial skill for any data professional. Hey there, I'm Yevgen. You're at our OryxBI YouTube channel where we speak all things about marketing, analytics, and data. On this channel, we help you do more with your data so you can tell the story of your business's success. So, if you are all about utilizing data, my friend, please subscribe to this channel and enable notifications so you don't miss any of the insights. Once again, in the first video of our SQL tutorial, we looked at how to select and retrieve data using SQL. You don't need to watch it before you watch this one, so don't worry about missing it. I'll drop a link in the description right below this video. I've also added timestamps in this video so you can jump around and if you want. With this being said, let's get started. Just like last time, we are going to use the BigQuery interface because it's one of the best data warehouses today, plus it's seamlessly integrated with other Google services like Google Analytics 4, Google Sheets we all work with. So, first things first, as we are going to speak mainly about tables today, let's define what exactly is a table in the context of a database. A table in SQL is essentially a structured format to store data. Table is a spreadsheet where every row represents a record and every column represents a specific attribute of that record. Tables are the backbone of any relational database, designed to hold your data in an organized manner. Let's see what a table looks like. Here on my screen, you can see the heroes table within our Marvel dataset. Notice how it's organized into columns like hero ID, name, alias, age, and origin. Each column is designed to store specific types of data. Each row is an entry in our database, and each column is our metric or dimension. If you're not familiar with what the differences is, I'll leave a link to another video in the description to this one. But long story short, metrics are numbers, and they measure things, and dimensions describe stuff. But they could be numbers as well, as our hero ID, for example. So each column is either a metric or dimension, and each row represents each specific hero on our list, with its attributes. Now, why it's so important to understand tables? Because every query you write, every analysis you perform starts here. From querying tabular data, whether you are pulling a list of all products out, checking the stock levels, or analyzing dummy datasets just like I'm doing right now, it begins with understanding how to interact with these tables. In the database, every piece of data falls into categories known as data types. So it's important to know what these are, because when you are setting up a table using SQL, you must specify the right type for each column of data you add. Now, let me go over the most common SQL data types that you will be using. First, we've got numbers. We mainly deal with three types here: int, float, and numeric. Int is short for integer, which means you'll be dealing with whole numbers, no decimals to see here. On the flip side, float is used for numbers that include decimals. When using float, you don't need to specify where the decimal should be. But you can also use numeric, which is sometimes also called decimal, if you have a fixed precision level. So basically, when you don't want to get surprised from rounding, such as financial calculations, use numeric. When you define a numeric field, you need to be clear about how big it can be. You'll specify the maximum number of digits it can hold, up to 38, and how many of those digits are after the decimal point, up to 9. It's a bit like saying, "Hey SQL, experience the number to be this big with this much precision. For text, or what we call dimensions in the data world, the go-to type is string. It can include any letters, numbers, symbols, special characters, up to a specified length. So if you are storing something like product description, string is your friend. Then we have dates. The date type is straightforward. Formatted as year, 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 month, month, day, day. Like 2023, 03, 15. If you need to get more specific, down to exact seconds, you can use timestamp. This type extends the date by adding the time of day, hour, minute, and second. It's perfect for logging events to the precise moment they occur, for example, in Google Analytics. These are just the basics, and there are more types you might encounter depending on your database system. Each type is tailored to help you structure your data in the most effective way possible, ensuring your database is not only well organized, but also primed for easy querying going forward. Remember, setting this up correctly from the get-go can save you a ton of headaches down the line. So, when creating a table, take a moment to ensure you are choosing the right data types for your data nature and the questions you are going to be asking this database for. Now, let's dive into how you can create a new table in SQL using my demo dataset as an example. Let's imagine we are creating a table to manage product inventory. This table will include details such as product ID, launch year, price, vendor, and sales performance in dollars. First up, defining the table in SQL is very straightforward. You'll start with create table statement. While SQL is not case sensitive, I'll still use all caps for SQL comments to make them stand out in the script. It's easier to read, especially when you start working with more complex queries. Here is how we roll. We'll name our table inventory, including the name of the project and the dataset in which the table should be created. That's something that is very important for BigQuery, that is not something that important for many of the other databases. But after typing this create table project ID dataset ID dot inventory, I open parentheses to start listing the fields. So let's break down the fields. Product ID. It's a unique identifier for each product, so we'll use integer. No decimals are needed for the product ID field. Straightforward integer values. Launch year. Also an integer, but remember, even though that's a year, we treat it like a number because it can be useful in calculations, like age in inventory, for example. Next, price. Here's where we use numeric because we are dealing with currency and often need precision for cents. So for our purposes, let's define it as a numeric parenthesis 7, 2. This means a maximum of 7 digits with 2 after the decimal point. Next, vendor. This is a text field, so string fits perfectly. It can include characters, numbers, and special symbols. BigQuery doesn't require a length specification for a string. However, some of the SQL databases do, so you can specify the number of characters in the parentheses. So, next, sales dollars. Similar to the price, but we'll use the float, because let's assume we might have a better figure here than in prices, and we don't know what there exactly could be. So float is more appropriate than numeric for specifying this total sales amount. Here is how the command looks. And once we run this, we get a brand new table ready in the specified dataset to store your retail data. Remember, if you try to create the same table twice, BigQuery will throw you an error saying the table already exists. This is how your database ensures that you do not accidentally overwrite existing data. Creating tables is like setting the stage for your data story. It's the first step. Each column should be carefully chosen to reflect the information that is the most important to your business model. So now, let's touch on how to tidy up your tables and manage constraints to ensure data integrity. When you've set up your tables, but need to remove one for any reason, SQL provides a neat way to do it with the drop table command. Just type drop table, project ID, dataset ID, .inventory, and click on run. So voila, the table is gone. Remember, SQL will alert you if you attempt to drop a table that doesn't exist. Now, diving into the nuts and bolts of maintaining your data integrity, we'll talk about constraints. Constraints are rules applied to the columns of a table to enforce data quality and accuracy. Here is a quick overview. Number 1. The primary key. A primary key is a unique identifier for each record in a table. In our inventory table, product ID could serve as an excellent primary key because it's unique to each product. By declaring a primary key, you ensure that no two rows have the same value in this column, and more importantly, a primary key cannot contain any null values. Here is how you'd set it up. Product ID int primary key. 2. Unique. The unique constraint is similar to a primary key, but allows for one null value. This constraint ensures that all values in a column are different from each other. If you have another field that you want to keep unique, perhaps a product code that might not be your primary key but still needs uniqueness, you can use the constraint product code string unique. 3. Not null. The not null constraint prevents null values from being entered into a column, ensuring that you always have a data in key fields. It's crucial for fields that are integral to your analytics but don't require uniqueness. For example, ensuring every product has a price could look like this. Price, numeric, parentheses 7,2, not null. These constraints help you maintain the quality and reliability of your data. Implementing them prevents common data errors, such as duplicates or missing values, which can lead to inaccurate decisions when you analyze data. By setting up these constraints, you shape the data entry process, making better data management and ensures the consistency and reliability of your data analytics. So each constraint plays its own role in how data interacts within your database ecosystem, making your data cleaner, your database operations more efficient. So it's just very important to use them from the very beginning. Now that our inventory table is set up, let's populate it with some data and start using this table for real business tasks. To do that, with SQL, we'll use the insert into command. Let me show you how it's done. In this command, I specify the columns we are filling: product ID, launch year, price, vendor, sales dollars, followed by the values for each row. And notice how each type of data fits the data type we defined earlier. Integers for product ID and launch year, numeric for price, and float for sales dollars. Strings, like the vendor's name, doesn't require single quotes in BigQuery. But if you're using other SQL databases, you might need to add them. Sometimes, you might not have all of the details for every column. SQL is flexible enough to handle this. You simply specify the column you do have data for. For example, let's say we want to add the new product, but we only know its ID and price. Running this will insert the new row with null values in the launch year, vendor, and sales dollar columns because we haven't provided any information for them. After inserting the data, it's always a good practice to check what's now in the table. Just type select asterisk from table. This command pulls up all of the records we've just inserted so we can verify that everything looks correct. Next, let's say you need to update some of the data you were entered. For instance, if the price of the product ID 103 was entered incorrectly and needs to be updated to 45.99. Here is how you do it. Update your table, set price equals 45.99, where product ID is 103. This command updates the price where the product ID matches 103. After running this, a select query would show the updated price. If for any reason you need to remove a product from the table, maybe it was discontinued, you can use the delete command. Delete from table where product ID equals 104. This command removes the product with the ID equals 104. Always use caution with delete to avoid removing the wrong data. And there you have it. We've just walked through how to insert, verify, update, and delete data using SQL. We've scattered the surface of SQL capabilities, yet what I've explained today lays a strong foundation, hopefully boosting your confidence to dive deeper into learning SQL. The skills I've shared today are really very important to managing your database effectively. As promised, SQL isn't as complicated as it seems, right? If this video has added value to your journey, please show your support by liking and sharing this video. Leave a comment down below if there is something specific you'd like to learn next, and subscribe to Ovoxbay YouTube channel, because your engagement fuels my passion to share more insights about working with data like this video. We are here to guide you every step of the way you enable your data. Thanks for tuning in. I'm Yevgen from Ovox, and remember, data always makes sense. So by next time, stay data-driven and keep exploring the opportunities your data brings in.